studied social science as an undergraduate. During that process of study, I got acquainted with open source software communities. They're building tools and data resources that were public. So I was really interested in this data commons as something that was a way to make value in the modern world. And so I actually learned how to program out of desire both to do research in social science and also to, in effect, create value for the world. And it was actually just luck that I ended up in genomics, because I had a friend who was working in a genomics research laboratory, and they're working on an early sequencing system. So by working on this system, I got acquainted with biology. Basically, that's how it began. And so I'm motivated for the future because of the possibility of actually working with organisms, like in the same way we work with code today. Pangenomics is a study of all genomes in a given context. The genome is the basic instructions that give rise to living organisms. And pangenomics just thinks about more than one genome at the same time in a total way. So a habit in our field is that we relate pieces of genomes to one genome that we're confident in. But what's happened recently is that we're able to make confident assemblies of many whole genomes. And so now we need to think about the total set, and that's why we start to call it pangenomics rather than just genomics. What advances do we expect to achieve because of working in pangenomics in humans? Obviously, it's hard to know what's in the unknown, and in effect, that's what we're looking into. It's a bit like the first probes that were sent on the other side of the moon. It's a bit like that. There are things we have not been able to see in our field that, because we can assemble and relate many genomes completely to each other, there should be the opportunity to learn in a complete way the mapping between the genome and the phenome, the genome and health. And this should hopefully resolve unanswered questions about something that we call missing heritability. So this is the fraction of phenotype, of expressed features of the organism, the individual, that we think should come from the genome, but we can't see in the DNA. I sincerely hope that by looking at complete genomes together, we'll be able to figure that out.